Question number 9, problem number 9, that is, from a height of 20 meters above a horizontal floor, a ball is thrown down with initial velocity 20 meters per second. After striking the floor, the ball bounces to the same height from which it was thrown. Find the coefficient of restitution for the collision between the ball and the floor. Take G is 10 meters per second square. Okay, here we have a one ball that is thrown downward direction uh, with initial velocity 20 meters per second from the 20 meters of the height. So this is our ground. It is our ground. From the ground there is a one object. Okay, so it is thrown. Initial velocity is given. U is equal to 20 meters per second. It is not a freely falling body. It is thrown by this velocity towards ground. Okay, it is about a height of 20 meters from the ground, and this ball is striking the ground with a velocity of u1. Before collision, the initial velocity we consider here u1. Then after striking, this ball is moving with up to same height. It is reached to the same height. Then after striking its velocity we consider here v1. Now we have to calculate the what is the coefficient of restitution between this collision. So first write down the given data here. So very first one, that initial velocity is given. Initial velocity u is equal to 20 meters per second. With this velocity it is moving downward, and h is also given, that is h is equal to 20 meters, and g value is also given, that is 10 meter per second square. Then it is moving from the 20 meters of height from the ground and striking with velocity u1. Now we have to find out the u1. For that we are using kinematical equation, that is v square minus u square is equal to 2as. From this v square means final means when this ball is reaching to the ground, that is u1 square, minus initial velocity, that is equal to 20 square is equal to 2 into minus g. A is minus g and s is minus h. Both are moving downward direction. So that is u1 square minus this is 20 square means 400 is equal to, this is 2 into minus it minus plus 2gh, and u1 square is equal to this 400 plus this is I'm taking to this side, and 2 into g is 10 and h is 20. That is 10 10, this is 400, and total it is equal to 800, and u1 is equal to under the root of 800. Then after striking the ground, it is moving with a velocity v1, and that v1 is equal to under the root of 2gh. We got this one derivation, after we will do it. Okay, so according to that, v1 is equal to under the root of 2 into 10 into, because it is reaching the same height, that is 20. So that is v1 is equal to under the root of, it is 40. Then coefficient of restitution. Coefficient of restitution. That is E is equal to, this is v2 minus v1 by u1 minus u2. Here v u2 means ground before collision, the second body velocity. After collision, the mm, collision velocity of the ground is v2. In the both cases it is equal to 0. Sorry, this is equal to 0, so that's why it is equal to 0 minus v1 by u1 minus 0, and that is equal to minus v1 by u1. So this is equal to v1. v1 is equal to under the root of 400 minus by, and here sorry, it is moving upward direction, we got here minus. Okay, minus into minus, here this will be plus, and u1 is equal to under the root of 800, and that is equal to 1 by root 2. This is our answer. So here minus 1, it is in the formula, and this is, it is moving downward direction. Okay, if it is got positive, then it is moving upward direction opposite to this one, that's why we got here negative. Then this negative value and this negative both are positive, and that is equal to 1 by root 2.